Hello everyone. Today I will discuss networks. For this lesson, I've used Creately to make all my diagrams. This image you see here is that of a human network. There are 6 people in this network: A, B, C, D, E, and F. A says something to D over the phone. D meets C in office and passes on the information during lunch. C then meets B at the gym and passes the information to her. B calls up F and tells her. Finally, F meets E at a park and tells him the same. This way, information is sent by A or the sender and is finally received by E or the receiver through a human network. Similarly, in computer science, you will see a network of devices. These devices can be laptops, mobile phones, tablets, printers, etc. Any device in the network is called the node, and the connection between the nodes are called the links. Links can be both cables or electromagnetic waves. The purpose of a network is to share resources and information. The node from where the sharing starts is called the sender, and the node that receives is called the receiver. When I say that the purpose of a network is to share resources, by resources I mean both hardware and software. Hardware is relatively simple. Hardware, for example, is a printer. Generally, in offices, multiple teams share a printer over a network. Software sharing is a little complicated. This basically means sharing a part of your computer over a network. Now, coming back to the purpose of a network, not only do we share resources over a network, but we also share information. For example, files. Now, network can be classified on various types based on the area it covers. WAN is Wide Area Network. It refers to the network that covers the entire world, precisely the internet. MAN or Metropolitan Area Network. There could be cities with their own Wi-Fi. That would be MAN. This could cover an area of about 50 kilometers. LAN is Local Area Network. This is used in offices, schools, colleges, etc. LAN can be set up without internet. PAN is Physical Area Network. This stretches up to a few meters, for example, the Bluetooth. And finally, BAN or Body Area Network refers to things like body sensors. Now, let's talk about WAN, the Wide Area Network, or the Internet. Let me tell you all how the Internet works. This, you see, is a modem. A modem is a modulator and a demodulator. It receives signal in analog form and converts it to digital form. It also has the capability of doing it vice versa. The router you see here picks up this data which has been converted to digital form by the modem and routes it to the destination. So if I have requested for some data on my computer from the internet, my computer becomes the destination. And how is the destination identified? By the IP or the Internet Protocol address. The router could either send the data to my computer using a cable or electromagnetic waves. every device on the network, be it the computer or the router, has something called the network interface card. The card has a port at the end of it. This you see here is the port of the NIC or the network interface card. So for the data to be transferred through the cable, an Ethernet cable needs to be used and has to be connected between the NIC of the router and that of the computer. The network interface card comes with a unique identification number the address called the MAC address or the Media Access Control address. This diagram, for example, shows how data is sent to the fourth computer or this computer. Computers, each of them have their own MAC and IP addresses. Initially, when the data transmission starts, the signal has two kinds of information with it. One, which is the final destination, identified the IP address, and second, the next device in the network identified by the MAC address. For example, when data gets sent to the fourth computer, the signal at router A has two kinds of information with it. The IP of the last computer, but since it does not reach the last computer directly, it contains the MAC address of router B. Here, once it reaches here, router B again has the same IP address, that of the fourth computer, but now it contains the MAC address of the next immediate device or that of router C. Here again the IP address remains unchanged, but the MAC address is now that of the fourth computer or the final destination. Now that we know how the internet works, I will move on to explaining networking models. Networking can be explained as models. These models are nothing but layers of hardware and software working together. Two such models are OSI model or the Open System Interconnection model or the TCP IP model or the Transmission Control Protocol Internet Protocol model. Let's discuss the OSI model. The first layer is the application layer or the layer that is presented to the user. The second layer is the presentation layer. It converts machine language into human readable form. The next is the session layer that keeps the session open while the data is exchanged. Next, the transport layer takes care of the data flow. The network layer that comes after that is nothing but the router. It locates the destination IP and routes the data. The data link layer helps address the physical device in the network with the help of the MAC address through the NIC. Physical layer is the physical data transmission layer. This is all about the model. Now, here, this is exactly what I had spoken about earlier. Here we see an example of how data is sent by computer A to server D. Though the signal contains two pieces of information that helps it get to the destination, the IP address and the MAC address, the IP address is the one that remains unchanged throughout the flow. The MAC address keeps on changing. The MAC address changes at every step of the transmission. The signal holds the MAC address of the immediate next device in the network. Finally, the last thing I want to discuss here in this lesson is network architecture. It can either be client-server architecture or peer-to-peer architecture. In client-server architecture, there's a central server that serves to all the other devices which request for some service. These devices or nodes are called clients. The client sends requests for a service to the server, and the server sends back a response to the client. The internet works in the client-server model. In peer-to-peer architecture, there is no central server. Every computer in the network acts both as a client and a server. Every machine makes both a request for a service to another machine and responds to the service request of some other machine. So that is it for today. Hope you've learned something new. I'll come back soon with my next video. Thank you.